Then we do have the condition there are three some kind of resistors in parallel. So at this point, if we would like to find this total resistance, we cannot do it normally. It means that right now we have to do the some kind of common way, 1 over R1 R2 plus R3. We are going to have 1 over R total, find this number, find the reciprocal of that, and your R total is going to be equal to 600 ohms. Then the question asks for a current inside each branch. Again, simple. The voltage for all of them is going to be 12 because all of them are in parallel with our main source. So I1 is V divided by R1. I2 divided V divided by R2, and R3 V divided by R3. If you do that one, you do have your current. If you would like to check that all of the answers are right, the only thing you can do is just add them all together, and you should still have the same current as the total current itself. So for the next one, we do have three resistors in parallel. It means that we need to maybe copy and paste, not copy and paste, copy only one of these guys like this. So three resistors, 1K. Let's just change it to 1K. Then we do have another resistance. The R2 should be 2.2K. Then we do have the final resistor should be 5.1K. Cool. We do have that. So the only thing we have to do is obviously connect this ammeter over here, then hit W, connect another wire, hit another W, connect over here, and then change the voltage source, make sure it is 12 volts. Hit OK. So let's find all of the currents. 19.8 milliamp as a total current, that is completely right. I do have the 1K, which should be 12 milliamp, completely right. 2.2K, 5.4 milliamp, right. And 5.1K, 2.3 milliamp. Another thing question asks for, I need the total resistance. Get rid of that. Draw output using the ohm meter, connect it like this. Forget about all of the readings. So we do have 605 ohm, that is completely right. So at this point, we do have the complex configuration, and we are going to deconstruct the combination that we do have about the series and parallel circuits. So let's talk about it. So the very first thing you have to know is how we can solve it, obviously, solving the combination of circuits when we do have the parallel block in series as well. Imagine that we do have this condition, that R1, R2, and R3 are all of them are connected to our voltage source. As you can see over here, R1 and R2 are connected into parallel. So first of all, we have to find the accumulation on all of that. We know it, R1 times R2 divided by R1 plus R2. Then we have to add it up with R3, and we can find the R total. So let's do it. So voltage source is 15 volt, R1 is 1K, R2 is 2.2K, and R3 is 3.3K. As I just told you, R1 and R2 are in parallel. So if I would like to find the parallel of the accumulation of these two, I do have this specific formula. So it would be something around 690 ohm. Then I have to add it up with R3, right? So the only thing I have to do is just add R12, which is another name for the accumulation of R1 and 2, which is in bit new index, plus R3. So final number is going to be something around 4K. So I do have everything that I need right now. So I can find the total current, which is 15 volt divided by 4K. This is something around 3.7 milliamp. Since I do have that one, I can simply find everything that I need. The very first thing that I need is the voltage of R3. We will talk about the voltage R1 and R2. The voltage R3 obviously is VR3 is equals I total multiplied by R3 itself. Simple. I total was what? 3.7 milliamp. And R3 was how much? 3.3K. Again, be careful. I do have milli, I do have K. These two things are going to cancel each other. So I do have ampere times ohm, which would be volt. So finally, I do have 12.4 volt. So V12, either I can find the current for each branch based on the current divider, or I can simply find the voltage of them using the voltage drop. We know the voltage of 1, 2 plus the voltage of 3, or the voltage drop of 3, should be Vs based on the KVL, right? So simply I can subtract this one out of Vs and I can find my V12. If you do that one, what you got? It would be something around 2.6 volts. And right now I can simply find the current inside each branch. 2.6, because I know the voltage over here to here is V12, and it's going to be the same for R1 and R2. Both of them are in parallel. So IR1 is going to be VR1. That we found again, VR1 and VR2 are going to be the same. So I do have 2.5 divided by 1K. This milliamp, this guy divided by this one, this milliamp. If you want to make sure that this current is right or not, you only have to add it up, and this addition should be as the same as this total one. Since we understand everything related to this circuit, let's talk about the simulation. So for the next one, we do have 3 resistors in parallel. It means that we need to maybe copy and paste, not copy and paste, copy only one of these guys like this. So 3 resistors, 1K. Let's just change it to 1K. Then we do have another resistance. The R2 should be 2.2K. Then we do have the final resistor should be 5.1K. Cool. We do have that. So the only thing we have to do is obviously connect this ammeter over here, then hit W, connect another wire, hit another W, connect over here, and then change the voltage source, make sure it is 12 volts. Hit OK, so let's find all of the currents. 19.8 milliamp has a total current, that is completely right. I do have the 1K, which should be 12 milliamp, completely right. 2.2K, 5.4 milliamp, right. And 5.1K, 2.3 milliamp. Another thing question asked for, I need the total resistance. Get rid of that. Draw output using the ohm meter, connected like this. Forget about all of the readings. So we do have 605 ohm, that is completely right. For the next part, we do have a little bit complex circuits. It means that our voltage, again, let's get rid of that so we know how to do it. Again, our voltage source should be like this. So we do have it as 15 volts. Then we do have a wire goes like this. Then we need 2 resistors side by side or in parallel. Hit R like this one, hit another R like this one, and after that we need obviously another resistor in series, hit this R. Then we need W to add wires, then another W to add this wire, then G or finding the ground from here to connect it like this. Then we need a W, oh by the way, let's move over here, W to move this guy to this guy, connect it. Then another W to connect these two guys, one W to connect over here, and another W to connect it over here, and finally, final W to be here. So I need what? On my R1 is 1K, my R2 is 2.2K, and my R3 is 3.3K. Okay, so right now I need a couple of things. The very first part is R12. Obviously R12, or there's some kind of the parallel part of R12, you can simply find this one. The very good thing is that you have so much freedom. So imagine I only need these two, right? I can copy and paste it just like this over here. Then go draw and use the ohm meter and connect it like this. By the way, the ohm meter doesn't have any polarity, so it doesn't matter. One wire over here, wire over here. So at this point I do have 6, 8, 7 as my final resistance for R1 and R2. Then I need the R total. So for R total, just you can copy and paste this guy over here like this, make it vertical, move this one and connect this one here. So I do have 4 kilo ohm. Just the answer that we have is 3,900, which is very close. So get rid of that. We don't need one, and get rid of this one as well. Connect this guy over here. So we are looking for the amount of current. Obviously, first is the total current, then the current inside each branch. The total current, which is moved from here to here, is the same as this one, but these two currents would be different. Based on the current divider, you can find it based on using the calculation, but we are going to prove it using the simulation itself. So go to draw, output, ammeter, and we can just have it. Again, I'm going to do like this. The positive side of the ammeter should be connected here, the negative side here. So we do have 3.7 milliamp, completely right. And let's move this guy a little bit over here because we need to add an ammeter over here as well. So let's zoom in a little bit. I do have this one. Okay, connected like this, connected like that. Let's use another one, connected like this and connected like that. Cool. So we do have 2.58 milliamp for 1K as we have for the answer. Then we do have 1.176 milliamp for the second current. Then it asks for different voltages, voltage of R3, the voltage of this guy, and the voltage of these two guys. So obviously we can find that, and then we can prove the KVL. Let's go to draw, output, and voltmeter. If you go there through that, you do have the voltmeter over here. Just connect it like this, connect it like that. Okay, we do have 12.413, which answer is 12.414. This is so similar. Just copy and paste this. like that one, use a wire, positive over here and another negative over here, 2.587. Also, if I use the voltmeter over here to be like that, I do have my connection over here and I do have my wire like this and like that. Okay, 15 volts, 2.5 volts, and 12.4 volts. As simple as that. I believe we have everything we need. Yes, that is totally fine. Right now, we do have another combination. At this point, again, I do have my R2 and R3 are in parallel, and they should be in series with R1. So again, we are going to do the same concept as we did from the last one over here. We are going to apply it this time. So unlike the last one, this section, we do have R2 and R3 in parallel, and we have to add it up with R1. So Vs is 12. R1 is 5.1K, R2 is 1K, and R3 is 3.3K. How can I find the parallel of R2 and R3? Simple. R2 multiplied by R3 divided by R2 plus R3. So if I do that, what I got, I do have my parallel section. It would be 767 ohm. Then I have to add it up with R1 because the accumulation of all of these, because call this as R23, is going to be series with R1. If I do that, if I add it up, it would be something like this as my around 5,800 ohm. So in order to find the total current, the only thing that I have to do, I have to divide the 12 volt by the whole resistance itself. So if I do that, I will have a number like this. Am I done? Obviously not. The question also asks for the current and voltage for each side. So in order to find the voltage of this one, I need to find the current. Since I do have the I total, the only thing I have to do is just VR1 equals I total times R1. So I total is the one that I already found it. Which, how much was that? 2.045 milliamps multiplied by R1, which how much was it? It was 5.1K. Milli and K are going to cancel out each other, and your final number is going to be this. For VR23, the only thing I have to do is just find the difference between Vs and VR1. If I do that, what I got, I do have 1.57 1.57 volts. Then I have to find the current that goes through this branch and this branch. By doing what? By just dividing that voltage or voltage of each section or each resistor, which we know is going to be the same, and we do have it as 1.57 volts by R2 and R3. If I do that, I would have something like this. So again, if you would like to check that your answer is right or not, add them up, and if you add them up, you still should have the same answer as I total itself. So let's check this one using our simulation itself to make sure that everything is fine. So for the next part, we do have a little bit of changing. It means that our resistor is going to be at this point, some kind of the series resistor, and power resistor should be at this point, which is still going to be the same, but the numbers are different. So V1 should be 12 volts. We are going to still use the previous one. And R1, which is going to be series, guys, should be 5.1K. Okay. And then our R2, which is going to be on the top, should be what? The R2 should be 1K, still 1K, and R2 should be R3 should be 3.3K. Okay, cool. So let's find everything we need. The very first part we need is the total resistance. Again, using the ohm meter, the draw and outputs, we have the ohm meter. It's going to be like this. Get rid of that. Connect that one. Connect the ohm meter like this. So we do have 5.9K as my total resistance. Oh, by the way, you see that what I did wrong? As I just told you, we have to get rid of the voltage source because it's going to cause so much problem. So at this point, what do I have? I do have 5.9K as my total resistance, which we do have it. Then we need the R23, the total resistance of these two guys. We can disconnect these two from the whole system, then connect the total resistance over here, ohm meter over here, and connect it like that. So we have 767.4, which is okay. Move Control Z, move to the previous parts. Okay, we do have everything that we need. Fine. So then we have to check the currents, obviously. The total current is 2.046 milliamp. The current inside this branch is 1.57. This one is 475 microamp. By the way, micro means 10 to the power negative 6, or we can say that 0.47 milliamp. If you add these two without any issue. So part 3, we are going to talk about the key concept and applications, applying the core principles like voltage division, KCL, and power. Just like the way that we know about them, right now we are going to apply them and make sure that